So this video is the solutions to the Chapter 4 review homework sheet. The questions are pretty straightforward, but I'll show you the solutions and go over them anyways. So let's try. Okay, so question 1 is just a simple conversion. So they gave you the angles in radians and they asked you to convert them into degrees. So as long as you know that pi radians is 180 degrees, you're pretty solid for this question. So I won't go over each one, and they said round it to 1 decimal place, no problem. For number 2, they gave me the angle in degrees and they asked me to convert to radians and round it to 2 decimal places. Once again, nothing too complicated, so those are my answers. Let's see number 3. Number 3, they gave me the angle in degrees and they asked me to find the angle in radians, but I leave it as an exact answer. So for number 1, or for number 2, we rounded it to 2 decimal places, but for number 3, their expectation is keep it as an exact answer. I really prefer exact answers, so on the test, if you can provide an exact answer, definitely leave it as exact. There's no reason for me to ask you to round it to 2 decimal places. Number 4, so they gave me the central angle, they gave me the radius, and asked me to solve for the arc length. As long as I know that theta, the angle in radians, is the ratio of the arc length to the radius, then you can easily solve for the arc length. Number 5, 5a is just finding the ratios, knowing your special angles and their respective ratios. So pi over 6, pi over 3, pi over 4. This question should be pretty straightforward because everything is in quadrant 1. So positive, positive, positive. Do some algebra, and there's your answer. For 5b, this one's a little harder because like 4 pi over 3 is in the third quadrant, 5 pi over 6 is in the second, 3 pi over 4 is in the second. So you have to, you might show a few more steps than I did, but you'll get the same answer hopefully. So for like secant 4 pi over 3, you might want to write it as 1 over cos of 4 pi over 3, and then go from there. And then say 1 over cos 4 pi, that's 1 over negative half. So just show a few extra steps. Show a few extra steps if you're having trouble doing it all in one step. Okay. So you take the reciprocal of negative half, you'll get what I wrote, which is negative 2. I know the ratios because I've had sufficient practice, but if you get the reps in, you'll be able to generate the ratios just as quickly. Okay, number 6 was, I believe, my favorite question on the handout. So we have Sherry and Leo. Sherry and Leo, they're looking at a hot air balloon. The angle that Sherry makes with, well, I think her angle of elevation is pi over 4, and the angle of elevation for Leo is pi over 3. And they asked me to find the height here. So I did this step here. I studied Sherry's triangle first, but I actually really didn't need to do that because I knew that if I looked at the left half of this triangle, this is not only is this this is a right triangle, this is also an isosceles triangle. Okay, how do I know? Because pi over 4, pi over 4, pi over 4. So this is an isosceles triangle, which means h and x must be the same length. So I didn't need to do all this math, but I did it anyways. Okay, so if I have this relationship h equals x, I can sub it in afterwards when I studied Leo's triangle using his angle of elevation, and then substitute x for h. So you see x over here is 36 minus x. It's no longer 36 minus x. I subbed it in because x and h are the same, so I wrote 36 minus h. That was actually one of the harder parts of the question. Where did this 36 minus x come from? Because they told me that Sherry and Leo are 36 meters apart. So I looked at the point underneath the hot air balloon. If Sherry to that point is x meters, then Leo to that point is 36 minus x. because the sum of the two distances must be 36. So this is x, this must be 36 minus x. And just follow some basic algebra and then solve for the height. About 22.8 meters. 7a, not much to say. They're really nice for 7 because it's two beautiful triangles, the 3, 4, 5 triangle and the 7, 24, 25 triangle. Be careful. They told us that angle A is in the second quadrant and B is in the third quadrant. So make sure you get the signs correct. But then evaluate and you get the answers. For 7c, it's using double angle formula. I would argue 7c is easier than 7a and 7b because the double angle formula for sine, you just need to know sine A and cos A and then you're done. You don't need sine B and cos B. Okay, so let's see what else we have. Okay, question 8, we have a ladder question. The minimum angle is pi over 12. So what's the minimum distance here? So if this angle is greater than pi over 12, then x becomes greater. So you're solving for the minimum distance, so let the angle be pi over 12. And you'll solve for the smallest value here. Because if you open up this angle here, x will become larger. So you want to solve for the minimum distance, you want to let this angle here be pi over 12. Anyways, pi over 12 is not our friend. What you have to do is break apart pi over 12 such that it becomes our friend. So pi over 12 is pi over 3 minus pi over 4. I express it as a difference of special angles and use a subtraction formula for sine, and then multiply both sides by 15, and I'm done. Number 9, basically you're proving an identity. To be honest with you, number 9 I didn't like it because I didn't use a single grade 12 trig identity. It's still good practice, it's still good to refine those algebraic skills, but I would have preferred if there was a grade 12 trig identity that I had to use. It was kind of tedious though. But all you have to do is using the reciprocal trig identity, cotan x is 1 over tan x, and then simplify, 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 and then you'll get there. Not much to say. Okay, number 10, they ask is an identity, so I tried to prove it, and I was able to prove it, so it is an identity. So how did I do it? I used the subtraction formula for cosine, subtraction formula for sine, and then I saw cos x cos square y, and I really want that cos x. So you could change this either way. You can make this work. You can change cos square y to become 1 minus sine square y, or you can change sine square y to 1 minus cos square y. Basically, once you're at this line here, the third line, you have two options. So I changed sine square y to 1 minus cos square because I just wanted cos, 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 because I saw cos on the right side of the identity, so I don't want to see a single sign. So change it all to cos and then simplify, and I'm done. All right, that's chapter 4 review.